Hi everyone! In this tutorial, I will show you the fastest and easiest way to calculate any nutrient solution for any plant and for any stage. For this, we are going to use this app called CropFeed. The app is available on Android for now, and hopefully there will be an iOS version in the future. The first step is to add our water formula. We go to the water page and tap Add. We give the formula a clear name so we can easily select it later when creating a recipe. For this example, we call it Water 1. All water analysis values on this page are entered in millimoles per liter. For this tutorial, we will use this water analysis. 6.20 millimoles per liter of bicarbonate, 0.30 millimoles per liter of sulfate, 1.80 millimoles per liter of calcium, 2.00 millimoles per liter of magnesium, 1.40 millimoles per liter of sodium, and 2.60 millimoles per liter of chloride. It is important to use our real water analysis, because CropFeed uses this water as the starting point for the final nutrient solution. After adding our water formula, we go to the calculator page. First, we select our water, in this case Water 1, as our water formula. Then we set the factor that we want. The factor determines how concentrated our stock solution is compared with the final irrigation water. Next, we set the tank volume to 1,000 liters. This tells CropFeed how much stock solution we want to prepare. Here, we can select the neutralizing acid that we want to use. The best choice normally depends on the acids available to us and on our target formula. If we want to add more nitrate, we can choose nitric acid. If we want to add more phosphate, we can choose phosphoric acid. If we want to add more sulfate, we can choose sulfuric acid. For this example, we choose nitric acid. Now we move to target concentrations. For this example, we choose millimoles per liter as our unit. First, we set the HCO3N to 0.60 millimoles per liter. This is the bicarbonate concentration that we want to remain in the final irrigation water. Then we type in our target values. These values depend on our crop and its growth stage. In our case, we will use a tomato crop formula for the fruit setting stage. As we enter the targets, CropFeed updates the target EC and shows the total anions and cations, so we can see whether the target formula is close to charge balanced. Below the macro targets, we move to the micronutrient targets. All micronutrient values are entered in micromoles per liter. For this tomato fruit setting example, we enter 20.00 for iron, 40.00 for boron, 15.00 for manganese, 8.00 for zinc, 1.50 for copper, and 0.50 for molybdenum. Just like the macro targets, these values should be adjusted based on the crop stage, water quality, and growing conditions. After entering our targets, we move to the fertilizer step. Here, we choose the fertilizer sources that we want CropFeed to use for this formula. For this example, we select calcium nitrate for calcium and nitrate, ammonium nitrate for ammonium and nitrate, potassium nitrate for potassium and nitrate, potassium sulfate for potassium and sulfate, and monopotassium phosphate for phosphate and potassium. We already selected nitric acid as our neutralizing acid. We do not need a magnesium fertilizer in this case because our water already contains 2.00 millimoles per liter of magnesium, which matches our target. Sodium and chloride also already meet their targets through the water. Once we have selected our fertilizer sources, we tap Solve. After we tap Solve, we go to Calculator Results. CropFeed now calculates the quantities needed for our 1,000-liter tank at a factor of 100. Each row shows the final quantity for one selected fertilizer. These quantities are not for 1,000 liters of final irrigation water. They are the quantities that we dissolve in our 1,000-liter stock tank. Because we selected a factor of 100, the stock solution is 100 times more concentrated than the irrigation water that reaches the crop. The irrigation system injects and dilutes this stock solution to produce the final nutrient concentrations that we entered as targets. So, if we mix these quantities in the stock tank and inject the solution at the selected factor until the irrigation water reaches the target EC shown by CropFeed. The final irrigation water will have the target concentrations we entered. After reviewing the solved quantities, we tap Apply to Mix. This copies the calculated quantities into the mix page. CropFeed separates the products into the appropriate stock tanks. Calcium fertilizers are kept separate from products such as sulfates and phosphates because mixing incompatible products in the same concentrated tank can cause precipitation. The neutralizing acid is kept in its own acid tank. Next, we check tank solubility. If a tank has a precipitation risk warning, we can lower the concentration factor, use a larger tank, or adjust the fertilizer sources before mixing. The check page is especially useful after we make a change on the mix page. If we change the quantity of any fertilizer, CropFeed recalculates the formula and shows how that change affects the final nutrient solution. We can also play with the EC and see what changes in the final formula. The result column shows the new concentration produced by the current recipe. The target column shows the concentration that we originally wanted, and delta shows the difference between them. This lets us quickly see which ions changed, how the EC changed, and how the cost of the mix changed after our adjustment. When the recipe is ready, use image or PDF export to share a clear mixing work order with your team. CropFeed is designed to make nutrient planning easier, but this example is for demonstration. Always adapt the recipe to your crop stage, climate, water analysis, and commercial fertilizer labels before use. If you have any questions, feel free to leave them in the comments below.